Hello everyone, I'm Bhagyashree from TCS Research. I'll be talking about our paper titled Plots to Previews towards automatic movie preview retrieval using publicly available metadata. Preview is a contiguous scene of a movie or a TV show highlighting its story, characters, and tone, thus helping viewers in quicker decision making. We aim at creating previews by availing readily available scene metadata while avoiding dependency on semantic scene level annotations. We hypothesize that a movie scene that best match publicly available IMDb plot summaries can make good previews. With this method, we get at least one good preview scene for 26 out of 51 movies as agreed upon by a critical expert judgment. We make use of movie graphs dataset for this work, which gives scene boundaries along with scene annotations for 51 movies. Here is an example of scene annotations from the movie Meet the Parents. There are scene subtitles and scene description, which are in the form of natural language sentences. Character attribute tags and interaction tags are in the form of words or phrases, which we later convert into the form of sentences. We formally define our null hypothesis as out of the candidate movie scenes, any randomly sampled scene is a good preview scene. And our alternative hypothesis as out of the candidate movie scenes, a movie scene that is ranked higher based on its similarity with the IMDb plot summary is a good preview scene. We find out the similarity score of jth candidate scene of the ith movie as the cosine similarity between embeddings of the feature of scene Sij and embeddings of the plot summary of the movie I, Pi. Because we do not have ground truth movie preview annotations, we evaluate the generated previews on the basis of these 4 evaluation criteria created on the basis of definition of the movie previews. First 3 criteria about story, characters, and feel talk about whether the scene gives the viewer a hint about story, characters, or feel of the movie. The decision-related criteria is that the scene helps the viewer in deciding whether to watch the movie. We get the user responses for these criteria on 5-point Likert scale. We also ask them a question: have you watched the movie this scene is from? Rather than before going for external user evaluation at larger scale, we first conduct internal pilot experiments to find out whether readily available features such as scene subtitles are adequate enough to get usable movie previews rather than using semantic scene level features. In the first pilot, we find out the similarity of plot summary with multiple semantic features, the PSMF experiment, where we use scene description, interaction statement, character attribute statement, and scene subtitles as the multiple features. We get 4 different rank lists based on similarity of each of these with the plot summary. We aggregate these rank lists with MC4 rank aggregation algorithm, and top 2 preview scenes are obtained of the final rank list are obtained as the preview scenes. In our second pilot experiment, we find out the similarity of the plot summary with just the scene subtitles as the scene features, the PSSS experiment. Here as well, we find the similarity of scene subtitles and plot summary by using cosine similarity score, and top 2 of the final ranked scenes are then selected as preview scenes. The table shows mean evaluation scores against all 4 statements for pilot and the main experiment. In the pilot experiment, it can be seen that the PSSS method using just the subtitles achieves comparable performance with the PSMF method. Hence, we conduct our main experiment where we evaluate the PSSS method from the expert rater, who is the screenplay and script writer, and also from the regular viewers. The Mann-Whitney U-test results show that the median evaluation scores of PSMF and PSSS, both methods are significantly greater than the random method. The histograms obtained for expert ratings show that the PSSS method, which is shown in the blue bar, has more agreements as compared to the random method and lesser disagreements as compared to the random method. Similar is the observation from histograms from the regular viewers. We compare the overall agreements for the decision statement by expert and regular viewers. It is observed that expert has lesser overall agreements, which indicates that expert has been critical in his judgment about the movie previews. We get 11 random scenes which were rated high by the expert and which were missed by our method. The error analysis indicates that the errors can be categorized into 4 categories. First, when there was an erroneous detection of subtitles itself in the dataset. Second, when there was a better verbal match with subtitles of some other scenes than the scenes rated high by the expert. Third, when the scenes were creating affect and curiosity using audio-visual features. Fourth, when there were mentions of multiple plot events in the plot summary. Since our method relies heavily on the match of plot summary with the scene subtitles, we tend to miss on scenes creating fields with audio-visual features. In future, we would also like to exploit the logline structure of the plot summary to get the inciting incidents from the plot summary. And we would also like to validate our method by using actual ground truth preview scenes. Thank you.